Okay, for number 11, we're given the square root of x plus 2 dy over dx equals x times the square root of y minus 1. And it wants us to find the general solution, so not the particular solution, which means we don't care about any initial conditions. So in order to find the general solution for differential equations, the first thing we want to do is get all our variables separated. We want to separate our variables, all the x's to one side, all the y's to the other. And in general, we put the y's on the left. It just makes it easier in the process. So I'm going to move my x's to the right and my y's to the left. Let me get a marker here. So we're going to have dy. I'm going to divide out this square root of y minus 1 equals, we're going to multiply the dx to the other side and divide the square root of x plus 2. So really we have x over square root of x plus 2 dx on the right side. This is what our equation looks like. So we've separated our variables. We again divided by y minus 1 on this side. We multiplied by dx and divided by x plus 2, square root of x plus 2 on the other side. The next step to do, once we have our variables separated, is to take the integral of both sides. Good Lord. Okay, so now we're going to take the integral of both sides. On the left side and on the right side, it looks like we're going to need some U-substitution. Because we don't have a chain rule, we don't have a quotient rule, we don't have anything like that for our integrals. So I'm going to say u on the left side is going to equal y minus 1. That means du equals, and what do we get? We just get 1 dy. So that's pretty helpful. So now we can rewrite this left side as square root of u, but it's a square root in the bottom. So I'm just going to write it as u to the negative 1/2. Okay, so really again we have du over square root of u, but I'm going to write this as u to the negative 1/2 because I think it'll make it easier to see the integration. And then we have to keep our du in there. Okay, so if we were to actually integrate this side, let's see if I have. Okay, if we're going to integrate this side, all we do is add 1, and then we have a plus c. Now we're going to have 2 plus c's, we're just going to add them to the right side at the end. So really we have u to the 1/2 over 1/2, which is the same as times 2. And our u was equal to y minus 1. So really it's 2 y minus 1 to the 1/2. And then there's a plus, like a c1. I'm just going to consider all of the c's on the right side, so I'm not going to worry about the left side c's. Okay, let's do the right side. So now we're probably going to have U-substitution here again. Our right side u, this is a different u. Maybe I should draw it in a different color. So this u, I would guess, is going to be x plus 2, just because that's the thing under the radical. So then we're going to have a du again that's just going to equal 1, and then with respect to whatever we're doing, which is going to be dx. Okay, so we're closer to being able to set this one up, but we still have that pesky x on the top. So we have x du square root of u. So now what we need to do is be able to get rid of this x and rewrite it in terms of u. Now the best way to do that is to take this first equation here and just move that 2 to the other side. So really also u minus 2 is equal to x. That's a true statement based on the variables that we've set up. So now this integral becomes, instead of x, it's u minus 2 over the square root of u du. This may not look a lot cleaner than what we started with, but it is, because now we just have one fraction at the bottom and we can separate it. Because this is the same as u over square root of u minus 2 over square root of u. And we could do those integrals separately. Now u to the 1 over u to the 1/2 is the same as u to the 1/2. So now this left side has become u to the positive 1/2 minus the right side is 2u to the negative 1/2, right? Because our radical is in the bottom. And again, all with respect to u. So du is going to be what we have there. Now when we integrate this side, we're just doing it the same way. So we're going to say plus 1, we get u to the 3/2 over 3/2. Then we're going to say minus 2u to the 1/2 over 1/2, so really it becomes times 2, which becomes 4, and then plus our c. Now at this point I would put your u back in. So our u on the blue side was equal to x plus 2. So we have 2/3 x plus 2 to the 3/2 minus 4x plus 2 to the 1/2 plus some constant c. Okay, and this was equal to, on the left side, 2y minus 1 to the 1/2. And again, we could have put a plus c on this side too. So we're just going to have a plus c somewhere. Now you're just solving for y, so you're going to divide by 2, take the square root, and add 1. That should get you the answer.